In this tutorial, we will cover the simplest possible audio chain for recording. In this case, the objective is to record a voiceover. The minimum configuration for recording requires a microphone, an audio interface capable of receiving the signal from a microphone, and a computer. To listen, we will also need speakers. Let's see a diagram that shows how these elements connect. The microphone connects by cable to one of the microphone inputs of the audio interface. The audio interface is connected to the computer through USB. The interface also connects to the speakers. Note that the way I refer to the connections respects the direction of the audio signal. The microphone connects to the interface and the interface connects to the speaker. Never the speaker connects to the interface, as this may be misleading and make you think that the signal goes from the speakers to the interface. Here at ESAD Studio we will have a slightly more complex system. There is also a multi-way extension to make it easier to connect several microphones without having to spread many cables, and the interface is also a digital mixing console that allows not only to prepare the audio for recording but also to communicate with the software. The first step is to mount the microphone on the tripod. The microphone tripod has several mechanical elements that can be used to adjust its shape in order to keep the microphone in the desired position. The base screw is used to fix the vertical pole without touching the floor. Height can be adjusted using the vertical pole handle. In the part that connects the arm to the vertical pole, we can adjust the angle and the extension of the arm. At the tip of the arm, there is a screw to attach the microphone holder. There are two sizes, and the microphone holder usually has the largest size and an adapter for the smallest. For example, in this arm for stereo capture, the screw is wide and it's necessary to remove the adapter from the holders. In order not to lose them, store them in the microphone box. The microphone holders are unique and designed according to the dimensions of the microphone for which they are intended. Microphone holders are always stored with the microphone and never left on the tripod. The holder will not fit other microphones and will leave its own microphone without mounting options if it's missing. There are also supports with shock absorbers. Both solutions are valid, but the ones with impact absorbers keep the mechanical noise away. But in any case, we are always limited to what the manufacturer decided for the microphone. To mount the microphone holder on the tripod, loosen the regulator that holds the rotation of the arm and tighten the tripod on the microphone holder. This way, you avoid possible accidents as the microphone is very secure, and if the cable is already connected while changing tripods, it will not wrap around the arm. At the end, do the opposite. Loosen the tripod arm from the microphone holder while holding it firmly. Put the microphone with its support in the case or box. There are several types of microphones, but the ones we have here in the sound studio are condensed microphones. This type of microphone uses a pickup capsule that is actually a capacitor. The vibrations of the sound make the distance between the plates of the capacitor vary, and this variation changes the value of the capacitor. With this value, the internal amplifier transforms this variation of capacitance into audio waves and sends them to the microphone plug. This type of microphone, because it has active electronic elements, needs electric current to work. This current is supplied by the mixer and it's called phantom power, usually at 48 volts. Professional microphones have an XLR male connector. The XLR plug has 3 contacts: positive, negative, and return. A cable with 3 contacts has the ability to send a balanced signal. This signal uses a subtraction technique to eliminate noise induced in the cable, which is why most connections made between professional equipment use this type of signal. We refer to connectors by name and type, in this case XLR, male or female. In XLR connections, the male connector always gives the signal and the female connector always receives the signal. The microphone always has a male connection and the input of the interface will always be female. Professional equipment also uses another type of plug, TRS. However, it is normal for the connector on the panel to be female and the cable plugs to be male. For this reason, it is more difficult to identify whether it is an input or an output. This mixer is the most complex element of this audio chain and the centerpiece of control in this studio. All the audio that we record and hear goes through this element in some way. It is an Allen and Heath Q16 mixer. The mixer is digital in both processing and control and has a built-in USB audio interface with access to all channels. This means that the computer will have access to all inputs and we can send audio to all outputs. This mixer was chosen for this studio because it has at least 6 independent outputs, which is a requirement to be able to connect all the speakers that make up the 5.1 surround system. The mixer is connected to the computer through USB and the computer is configured to use the mixer as an audio interface. This means that the volume buttons have no effect, the volume is now physically controlled on the mixer fader, and that the computer's built-in speakers and microphone are not working. Although the mixer is complex, it is programmed for easy use. To ensure that you are at the base point to start working, we must make sure that we are seeing the base options in your base configuration. To do this, we start by calling the preset surround that contains the recorded base state. We press Scene, choose Surround, press Recall, and confirm. It is possible for the faders to move to the recorded position. Avoid placing objects on top of the mixer and obstructing their movement. Press Processing to return to the Select Channel page. The second and third step will be to confirm that we are seeing the correct layer of faders. In this layer button, we can switch between inputs, outputs, and custom. Press both at the same time to choose custom. In this layer, the functionalities of the faders were programmed to have 10 inputs and 6 outputs. In practice, it is not necessary to change the layer for recording up to 10 microphones. The last step is to ensure that we are seeing the layer of faders for the correct output. If we choose the outputs master LR, we are seeing the faders that represent the final volumes. It looks complicated, but it is configured in a way where it is not necessary to navigate through all the different layers. So here we have the first 10 input channels, here the volume of the computer, and here the volume of the speakers. In the case of the computer, this fader controls the front left and front right channels. This controls the center and the LFE or low frequency effect. And this controls the surround left and surround right. In the case of the monitoring, the order is the same. This fade controls the front left and front right speakers. This one the center and the low frequency effect. And this one the left and right surround. The speaker level must be set to 0 decibels and the computer can go up to 0 decibels. However, it is more comfortable to work between -20 and -30. The decibel scale is logarithmic, so non-linear, and in audio equipment it is used as a factor or term of comparison. This means that if the channel is set to 0, we will have at the output exactly what we feed in the input, with 0 decibels of amplification or attenuation. If the fader is set to +5 decibels, it means that the audio will be amplified by 5 decibels compared to the original, and if it's negative, the same happens as attenuation. Normally the scale tends to vary between -infinite and +15, but it can vary depending on the equipment's manufacturer. In this case, the scale is between -infinity and +10. On an analog mixer, each channel has its individual controls. Each channel is a slice equal to the next. In the case of a digital mixer, this equality also exists, but it's more on the software side and not exactly on the buttons on the interface. Therefore, each channel is an abstraction and there are only the essential commands for the operation of the mixer in a live show environment, where the most of the features are pre-prepared and during the show only a few need to be adjusted. In this case, we have a mute, select, pre and after fade listening, a small view meter, and one fader per channel. All other configurations are represented by these commands, which serves all channels, but specifically the one that is selected. By pressing Cell from channel 1, for example, all these buttons, encoders and touchscreen are controlling channel 1. Each channel has a wide range of functions, but for recording we only need one: the gain of the preamplifier. Gain is the first process that audio undergoes when it enters the mixer. The gain controls a preamplifier that is used to amplify the level of the signal that enters the channel so that it has the correct intensity for the mixer to work with, and eventually to level all the signals that enter the mixer. After gain, it's supposed that all instruments have the same intensity with the output faders at 0 decibels. Before adjusting the gain, it may be necessary to turn on the phantom power, depending on the microphones used. If it is a condensed microphone, the 48 volts of power must be active, and to activate it, you must press and hold this button on the screen of the mixer until it activates. To find out how much we should increase the gain, we must follow the indications of the channel's view meter. The sound produced in its strongest form should make the yellow lights flash. Lower than that and we are wasting the dynamic range that the mixer supports, and higher, on the reds, it will distort. The correct adjustment of the gain is the most important and fundamental procedure for a good capture. Insufficient or saturated levels must be avoided. The software used in this example will be Adobe Audition, but the process is similar for all audio programs. First, we have to create a project and save it in a folder. Avoid the desktop and the untitled name. Once the program is open, go to the File menu and choose New Multitrack Session. In the window that opens, enter the name of the project. Choose a parent folder on the disk, knowing that Audition will create a child folder with the name of the project, and configure the audio settings to 48,000 Hz, 24 bits, stereo. As I said, within the parent folder, Audition created another one for the project using the name of the session. Inside that folder, we have the Audition project file and an automatic backup folder. Later, when we record, a folder called Recorded will appear here with the recorded files. The editor window is where we find the tracks and clips represented in time. The mixer window shows the controls of the tracks as if it were a mixer. The media browser window gives access to the disk and files on the computer. The files window shows the files that we are using in our session, and the levels window shows a view meter that represents the intensity of the audio at the master output. In the window menu, you can also enable or disable many other windows with more features, but for simple recording and editing, these ones will be enough. In the editor window, at the top left, we have 4 buttons that show different track controls pages: Inputs and Outputs, Effects, Sends, and Equalizer. To record, it will be necessary to tell the Audition in which track we are going to record on and from which microphone we are getting the audio. As an example, on track 3, I will choose the microphone 9. On the Input-Output page, in the first menu on track 3, I choose Mono 9. Mono because we only have one microphone. Sometimes these controls are hidden due to the vertical size of the track. I choose channel 9 of the interface as input to this track because that's where I have my microphone connected. But the Audition still doesn't know that is to record here on track 3. To activate recording on this track, you must press this button that has an R, arm for record, to arm the track. As soon as you press the rec button, the red circle, all armed tracks will record their respective inputs. At the end, press space key to stop. If you press space while stopped, the Audition will reproduce all the tracks that are open, without mute, or with solo.